Borosilicate glass is a type of glass with silica and boron trioxide as the main glass-forming constituents. Borosilicate glasses are known for having very low coefficients of thermal expansion, 3 times 10 to 6 K1 at 20 degrees Celsius, making them more resistant to thermal shock than any other common glass. Such glass is subjected to less thermal stress and can withstand temperature differentials without fracturing of about 165 degrees Celsius, 329 degrees Fahrenheit. 1. It is commonly used for the construction of reagent bottles. Borosilicate glass is sold under various trade names, including Borosil, Duran, Pyrex, Supertek, Suprax, Simax, BSA60, BSA51, by NIPRO, Heatex, Endural, Schott, Refmex, Kimble, and MG, India. Borosilicate glass was first developed by the German glassmaker Otto Schott in the late 19th century in Jena. This early borosilicate glass thus came to be known as Jena glass. Otto Schott was also the founder of today's Schott AG, which has sold borosilicate glass later under the brand name Duran. As part of an equity carve-out in 2005, the Duran Group was founded and the manufacture of Duran was transferred to it. After Corning Glass Works introduced Pyrex in 1915, the name became synonymous for borosilicate glass in the English-speaking world, though, in reality, a sizable portion of the glass produced under the Pyrex brand has also been made of soda-lime glass since the 1940s. However, borosilicate glass is the name of a glass family with various members tailored to completely different purposes. Most common today is borosilicate 3.3 glass such as Duran, International Cookware's NIPRO BSA60, and BSA51. In addition to quartz, sodium carbonate, and aluminium oxide traditionally used in glass making, boron is used in the manufacture of borosilicate glass. The composition of low-expansion borosilicate glass, such as those laboratory glasses mentioned above, is approximately 80% silica, 13% boric oxide, 4% sodium oxide and 2 to 3% aluminium oxide. Though more difficult to make than traditional glass due to the high melting temperature required, it is economical to produce. Its superior durability, chemical and heat resistance finds use in chemical laboratory equipment, cookware, lighting, and in certain kinds of windows. Borosilicate glass is created by combining and melting boric oxide, silica sand, soda ash, and alumina. Since borosilicate glass melts at a higher temperature than ordinary silicate glass, some new techniques were required for industrial production. The manufacturing process depends on the product geometry and can be differentiated between different methods like floating, tube drawing, or molding. The common type of borosilicate glass used for laboratory glassware has a very low thermal expansion coefficient, 3.3 times 10 to 6 K1, 3, about one-third that of ordinary soda-lime glass. This reduces material stresses caused by temperature gradients, which makes borosilicate a more suitable type of glass for certain applications, see below. Fused quartzware is even better in this respect, having 1/15 the thermal expansion of soda-lime glass. However, the difficulty of working with fused quartz makes quartzware much more expensive, and borosilicate glass is a low-cost compromise. While more resistant to thermal shock than other types of glass, borosilicate glass can still crack or shatter when subjected to rapid or uneven temperature variations. Among the characteristic properties of this glass family are the softening point, temperature at which viscosity is approximately 107.6 poise, of type 7740 Pyrex is 820 degrees Celsius, 1510 degrees Fahrenheit. 4. Borosilicate glass is less dense, about 2.23 grams/cm3, than typical soda-lime glass due to the low atomic mass of boron. Its mean specific heat capacity at constant pressure, 20 to 100 degrees Celsius, is 0.83 J/G middle.K, roughly 1/5 of water's. 5. The temperature differential that borosilicate glass can withstand before fracturing is about 165 degrees Celsius, 329 degrees Fahrenheit. This compares well with soda-lime glass, which can withstand only a 37 degrees Celsius, 99 degrees Fahrenheit, change in temperature and is why typical kitchenware made from traditional soda-lime glass will shatter if a vessel containing boiling water is placed on ice, but Pyrex or other borosilicate laboratory glass will not. 1. Optically, borosilicate glasses are crown glasses with low dispersion, Abbe numbers around 65, and relatively low refractive indices, 1.51 to 1.54 across the visible range. For the purposes of classification, borosilicate glass can be roughly arranged in the following groups, according to their oxide composition, in mass fractions. Characteristic of borosilicate glasses is the presence of substantial amounts of silica, CO2, and boric oxide, B2O3, greater than 8%, as glass network formers. The amount of boric oxide affects the glass properties in a particular way. Apart from the highly resistant varieties, B2O3 up to a maximum of 13%, there are others that, due to the different way in which the boric oxide is incorporated into the structural network, have only low chemical resistance, B2O3 content over 15%. Hence we differentiate between the following subtypes. The B2O3 content for borosilicate glass is typically 12 to 13% and the CO2 content over 80%. High chemical durability and low thermal expansion, 3.3 times 10 to 6 K1, the lowest of all commercial glasses for large-scale technical applications, make this a multi-talented glass material. High-grade borosilicate flat glasses are used in a wide variety of industries, mainly for technical applications that require either good thermal resistance, excellent chemical durability, or high light transmission in combination with a pristine surface quality. Other typical applications for different forms of borosilicate glass include glass tubing, glass piping, glass containers, etc., especially for the chemical industry. In addition to about 75% CO2 and 8 to 12% B2O3, these glasses contain up to 5% alkaline earths and alumina, Al2O3. This is a subtype of slightly softer glasses, which have thermal expansions in the range 4.0 to 5.0 times 10 to 6 K1.